Welcome to Body Unified Flow, where we simplify complexity and amplify performance. Today, we're going to take a hard look at a powerful productivity tool that, well, it might not be nearly as reliable as you think. We're exploring the pitfalls of traditional work sampling.
For decades, this has been the go-to technique for figuring out how work actually gets done. But today, we're not just going to talk about the promises. We're going to pull back the curtain and really examine the pitfalls. We'll get into the hidden biases and the very real limitations that every single manager, every analyst has to understand if they want to avoid making some pretty costly mistakes.
So, here's our game plan. First, we'll look at work sampling's powerful promise. Then we'll find the cracks in its statistical foundation. We'll dive into the unseen human element, see what happens when theory meets messy reality, and finally, figure out how to use this flawed tool wisely. By the end of this session, you won't just know what work sampling is. Nope, you'll be equipped to spot a flawed study from a mile away and to look at its data with a healthy dose of skepticism it truly deserves.
Okay, let's dive right in. To really understand the flaws, we first have to appreciate the power of the original idea. I mean, why did work sampling become such an industry standard in the first place?
So, at its core, the technique, which was first developed by LHC Tippett as something called the ratio delay study, is based on a really simple but powerful idea. The premise is this: if you take a random sample from a large group, that sample is probably going to look a lot like the group itself. You observe a small part to understand the whole. Pretty clever, right?
And its promise is incredibly compelling. See, unlike a time study that asks, how long does this specific task take, work sampling asks a bigger question. What proportion of our day is spent on all these different activities? And that shift in focus helps managers see the bigger picture. It's how you identify those hidden costs, like waiting for materials or waiting for instructions, things that are often the real culprits behind inefficiency.
All right, so that's the promise. But now let's start to deconstruct it. We're going to see how the very statistical principles that give work sampling its power can also be its greatest weakness, its Achilles heel.
You see, the entire validity of a work sampling study, the whole thing, rests on one critical principle: randomness. If those snapshots aren't truly random, the picture they create isn't just a little bit off, it's fundamentally wrong. So we have to ask this question. Now, this might seem really basic, but you'd be surprised how often this is where a study goes wrong. If an observer shows up at predictable times, 5 minutes after the hour, every hour, they aren't sampling the entire workday. They're just sampling a very specific and probably more productive part of it. The result? Management looks at the report and thinks everything is running perfectly, completely missing the chaos right before breaks or at the end of the shift, which is exactly where the real problems are usually hiding.
So here's the crucial point. For the stats to be reliable, you need a lot of data. This is because of something called the law of large numbers, which basically just says that the more times you observe something, the closer your average gets to the real average. The problem is, in the real world, studies are constrained by time and budgets. They don't collect enough observations. They become underpowered, which is just a statistical way of saying their results could be nothing more than random noise. Imagine making a multi-million-dollar decision based on a study that was basically a statistical fluke. That's the risk you're running.
Okay, now let's explore maybe the most fascinating flaw of all. One that you can't solve with statistics alone. This is about the psychological biases that pop up when human beings are observing other human beings. This brings us to a really famous phenomenon in social science known as the Hawthorne effect. Or you can just call it the observer effect. It's simple. When people know they're being watched, they don't act naturally, they perform. And this breaks it down perfectly. An analyst walks onto the factory floor. A worker who was just chatting immediately starts looking busy. The analyst records productive work. If this happens over and over, the final report shows this fantasy level of productivity. And the so what here is huge. This isn't just about bad data. It leads to management setting totally unrealistic performance targets. And that leads directly to employee burnout, frustration, and a deep sense of mistrust, because workers feel like they're being held to an impossible standard.
So how do the pros try to deal with this? Well, the key is to record the activity at the very instant of observation, before the worker even has a chance to react. Using neutral third-party observers instead of a direct manager can also help, because it reduces that pressure to perform for the boss. But ultimately, you can only minimize this effect. You can't eliminate it completely.
Okay, so let's see what happens when we take these theoretical challenges out of the nice, controlled factory and into complex, real-world environments, like a construction site. This is where a theory really smacks into messy reality.
Look, the sources are crystal clear on this. Manual observation is a grind. On a construction site, the environment is never the same from one minute to the next. It's not a controlled setting. On top of that, traditional work sampling lacks spatial context. It might tell you what someone is doing, but it doesn't tell you where, which is critical for understanding the flow of work. Oh, and good luck getting volunteers from workers on price work who get paid for their output and see any kind of interruption as a direct hit to their wallet.
And now for one of the most common and frankly catastrophic failures in a work sampling study. And it all comes down to something that sounds so deceptively simple: having poor definitions for your activity categories.
Just think about it for a second. An observer sees a worker standing still. Is he idle, or is he planning his next move? Is he waiting for a delivery, or is he waiting for a supervisor? Each of those tells a completely different story about what's going on. The consequence of getting this wrong is massive. A report might show 15% of time is idle, leading management to crack down on breaks, when the real problem was waiting for instructions, which is a management issue. You end up solving the wrong problem, wasting a ton of resources, and demoralizing your entire team.
So, after taking this tool completely apart, what's the verdict? Is it useless? Not at all, but it absolutely requires a new level of critical thinking. We can't just accept the final numbers at face value, we have to question how they were created in the first place. So let's recap. We've seen that the potential for major error exists at every single level of this process. The statistical foundation can be shaky, the psychological impact of being observed can distort behavior, and the practical challenges of just doing it can corrupt the data before it's even written down.
So now you have the framework. You can look beyond the surface of a productivity report and actually analyze its foundations. You've moved from being a passive consumer of data to a critical, informed analyst.
And this is the crucial takeaway. The methodology is everything. A beautiful chart means nothing if the data behind it was collected with predictable timing, vague definitions, and without accounting for the simple fact that people act differently when they're being watched. The real insight isn't in the final number, but in understanding its origins.
For anyone who wants to dive even deeper, the resources that were cited in our source material are an excellent starting point. Thanks for joining us.